Welcome to my PlayHouse, and today I want to talk to you about RAID. In servers like this, you usually run with a RAID system. What is RAID? RAID is a way of having disks work together in a specific way. And there are more levels of RAID. I want to go into these. Nowadays it's pretty normal to have a software RAID, where you just have the software see all the disks, and that makes the RAID system on them. But in the old days, before the processors was as powerful as they are today, we had big RAID cards like this. This would be a RAID card. It's an old one, but this is a RAID card for SCSI disks. And this was actually a fairly big one. This one was able to RAID across 2 channels of SCSI disks, and each change could be, I think, 15 or 16 disks. So that would be a very big RAID. And this was a very powerful RAID controller at the time. And it even had some memory, and it also had some battery backup. You can see the batteries, that's the black things here. So the data is written by the operating system and it's sent to the RAID controller, and the RAID controller just immediately says, okay, I got it, even though it hasn't been written to disk yet. So it's just written to the memory, and the RAID controller will keep it in an event of power loss. The RAID controllers has become smaller. This is kind of an enterprise level 1, and this is for SAS drives. Can also be used with SATA drives. This was a controller that came with all the IBM M2s and M3s. It was a very standard one, and you couldn't do a RAID 5 or RAID 6. So we always just took this out and put in a better one. So I have a bunch of these laying around. But let's go into the table where it's more quiet and have a talk about what RAID can be used for, and when it's good, and what are you really looking for. RAID, R-A-I-D, and it stands for Redundant Array of Independent Disks. This means that you can have some hard drives, right? Or this can also be other things than hard drive, but usually when we do talk about RAID, we are talking about hard drives or solid state drives. 2 hard drives like this. For the fun of it, we're just gonna say that each of these contains 100 gigabytes of data, even though they don't. These are different sizes, but just for this exercise, each of these disks are 100 gigabytes. So 2 of these disks are 200 gigabytes, and well, sometimes you have a bad disk. This one is, for example, it's bad. I've actually written bad on this one, and that's because it's probably dead. And if you're running a server or anything, you don't really want dead hard drives, but it happens all the time. So you want to ensure yourself that you can, if you have a hard drive fail on you, and you will have a hard drive fail on you, they do that. It's a very common thing to change out hard drives because they die. They have a lot of moving parts, a lot of really fast moving parts actually. Inside of the hard drive is a spinning discs, and it rotates. This one is with 10,000 rounds per minute, so it's really fast. This one is with 15,000 rounds per minute. So, well, the bearings wear out, the oil wear out, and the disk will crash. All the circuit board on the bottom of it will die, and you cannot access that data anymore. So therefore, somebody very smart invented RAID. And what this does is that it takes a minimum of 2 hard drives, and it makes a RAID system out of it, so that you can have the data on this drive, or you can split the data on the 2 drives. Let's go into the different RAID numbers. There is something called a RAID 0. We're just gonna call it R0, and it's not a resistor. That's a RAID model, and there is a RAID 1, and that is also a RAID model. The RAID 0, that's called striping, right? And this means that if you install 2 disks in your server, it can be more disks, but the minimum of a RAID 0 is 2 disks. So we're just going to be taking the minimum. When you write data, you will write, to make this simple, if you have an MP3 file, you will write half of the MP3 files to each of the disks. With Striped, you get 100 gigabytes here and 100 gigabytes here. You write half of the MP3 file to this disk and the other half of the MP3 file to this disk. This means that you can actually write the MP3 file really fast to the disk, because you can send half of it to each of the disks and they will be ready to take on the MP3 file. That's brilliant. But if this one becomes this one, turns bad, well, you only have half of the MP3 files, and that's not good for anything. There is no security in a striped array, and that's a bad thing. The upside is that this is very fast. Also, if you want to retrieve your MP3 file, you ask for it, and there is 2 disks that throw back the MP3 file for you. Here you go. And that's very fast, but no security whatsoever. Then there is RAID 1, and that's mirroring. And in this case, you have your 2 hard drives, and we are still going under the assumption that these are 100 gigabyte drives. So you have 100 gigabytes here, 100 gigabytes here. And this time we come with our MP3 file, and it's copied to both disks at this kind of the same time. Now we have the MP3 files on 2 disks. It's also very quick, because if we do ask for the MP3 file back, it retrieves it really quick, because it can actually take half of the MP3 files from each of the disks and just send that back. That's different from RAID controller to RAID controller, how they see and do that. It is about the same speed as a striped disk set. In some occasions it can be slower, and in other it can be faster. But this is also very, very fast, because there is no calculations going into this. This is very, very standard things. And you have the security of, if you lose a disk, well, all the data is on this one. But you do lose half the data, because 100 gigabytes, and you have a copy. So you only have 100 gigabytes of storage, even though you have 200 gigabytes of available disk space. So half of the storage is lost in mirroring. Mirroring don't have to be on 2 disks. It can also be on 4 disks, like that. Usually, I've only seen this in they're upside down, aren't they? I've only seen it in an equal number of disks. I've never seen 3 disks in a mirror. So this would be a good solution also. And you can mirror across these. There is also RAID 2, 3 and 4. They are not very widely used. You never ever come across them. The next really common one is RAID 5. Well, RAID 5, that's a kind of striping, but it comes with security. For doing a RAID 5, you need 3 disks. This. Oh, yeah, gotta take another one. This one is still bad. We have 3 disks here, and when I write my MP3 file, half of the data will go to this disk, half of the data will go to this disk, and the last disk will be a checksum of the data on these disks. And it's very smartly mathematically done, so that data on this disk and data on this disk, if I take out a disk, then we have data on this disk, and we have the checksum of what the data was with this disk and without this disk. From the checksum and the available data, it can calculate what was on this disk. So even though it's missing a disk, it still has the data. It takes a bit of calculation to straighten that out. If a disk dies, it slows down the system, but it actually have all the data even, and it's not like any of these 3 disks can die and data is still there. So this is a good way, because you have 100 gigabytes here, 100 gigabytes here, and 100 gigabytes here, and you lose 1 disk for security. So you get 200 gigabytes of data, but you put 300 gigabytes into it, and it's better than a RAID 1 where you put in 200 gigabytes and you have 100 gigabytes of data. So, and it's not, the minimum is 3 disks, but you can easily have more disks in a RAID 5. So in this way, data is on all 5 disks. If you take one out, data is still obtained on the 4 disks. So here you put in 500 gigabytes of data storage. You can take out one, so now you have 400 gigabytes of data left when you take out the security of the system. So this is a very widely used system. It doesn't really have a name, but it's minimum 3 disks. Then we have the next popular one, and that's called RAID 6. There. RAID 6 is very much like RAID 5. It's just have a higher level of security. And to do a RAID 6, you need 4 disks. And this one is upside down. Okay, doesn't matter, but this could be a RAID 6. And RAID 6 means that it's more or less the same thing that RAID 5, but you have 2 disks for checksum. So in this setup, you put in 400 gigabytes of storage. You can take out 2 disks and your data is still on these and good. RAID 6 has some advantages over RAID 5. You have 2 disks security, and it's not these 2 disks, it's any of these 2 disks you can take out and your data is still there. But should you lose 1 disk, then the system will normally alert you that you have downgraded your system and you would need to put in another disk. So let's see, this is a new disk and you put this in. Then it has to rebuild the system, but it has all the data because it has double checksum. So it's very fast to put in this new disk that replaces the broken one, because all data is available. It doesn't have to do much calculating to give you the data on this one. Where in a RAID 5, where you have 3 disks, 2 of them with data and 1 with a checksum, if you lose a disk and replace it with another disk, well, then it has to calculate all the data that was on this disk out of the 2 disks that were here. That takes quite a bit of calculation speed and quite a bit of time. And while it's doing that and working really hard on the 2 drives left, well, if you should lose one more, that's a really bad thing. But with a RAID 6, you have 4 disks. This is a minimum of 4 disks, and should you lose one, you're still good. And when you put in another one, you're still good. And it's a lot faster to rebuild this because we have all the data available for us, and we don't need to stress the disks as much while we are rebuilding. RAID 5 and RAID 6 is slower than RAID 0 and RAID 1. And that's because of all the calculations that are involved in storing data and retrieving data. Very often you will see that there's different speeds for storing data and for reading data. And that's because it has to split up the data and do some calculations when it's storing or reading it. You can see if this is a RAID 6, if we have to retrieve our MP3 file, we can access any of these disks. The MP3 file should be on more of these disks, so maybe it's on these 3, maybe it's on these 3. It shouldn't really have to access all 4 disks to get the MP3 file, but it can. Yeah, this costs a little bit in the calculation area, and that's why a RAID controller is really a good thing when you are dealing with this. The big storage vendors, they recommend at least RAID 6. So if you have a big box of disks, they say that RAID 5 is too small. The minimum is RAID 6. The next one we come across, there's a lot of in-betweens here. I'm just picking some of them. The next one is a RAID 10. And that is a mirrored stripe. The numbers are actually the 1 and the 0. So first we mirror it and then we stripe it. So here we have a minimum of 4 disks. And there is 2 disk security here, 1 disk security here, 1 disk security here, 0 disk security here. RAID 10 needs a minimum of 4 disks. Here we have 4 disks. And if we do a mirroring on these 2 and a mirroring on these 2, and then we stripe these 2 arrays together, we have a RAID 10. That means that when I come with my MP3 file, it will be split into 2. It want to save it on this mirror and on this mirror, but it comes in this way and it's split in 2, and half of it is saved over here and half of it is saved over here. The advantage of this is that this is very quick. It costs a lot of disk space because half of this is security, right? First it's split into 2, then it's copied to 2 disks. This means that the reading and writing to a RAID 10 is fairly quick because it's a very easy operation to split up an MP3 file and save half of it over here and half of it over here. The disadvantages is that you are involving a lot of disks, and that's a good thing and that's a bad thing. But well, that's how it works. You have a fairly good disk speed. You have 2 disk securities, but in a way that you cannot lose these 2 disks. That's a bad thing. So you have 1 disk security on each side of this setup. So we can lose these 2 and our data is still good. We can lose these 2 and our data is still good. And but we cannot lose these 2 because that's 1 mirror and that's 1 mirror, and then there is stripe between those 2. So that's another. It's an expensive way to go, but it's widely used. And now I'm running out of room on my paper here. So let's go to the next page. Then we have R50. Oh, that's not 50. R50. RAID 50. For that one we need a lot of disks. And we'll involve these bad ones. Right now they're good. Okay. This one is not being used. This could be an R50. On each of these 2 we have a RAID 5, and then across the 2 RAID 5 we have a striped. So my MP3 files comes in here. It's split into 2. Half of it goes over here, half of it goes over here, and then it's saved on each of these RAID 5 systems. This means that over here we can lose any one of these disks and we'll still be good. We cannot lose all of these disks, then we're out. That's not a good idea. Then we lose our data. Well, we can lose 1 disk on each side. This is not smart when you have 3 disks on each side. That's stupid, right? If you have 12 disks on each side, this makes a lot of sense. And mostly because this gives us a lot of speed. The splitting up of data is really good. The controller handles that very fast, and it can tell these disks over here, write that data, and it can tell these disks over here, write that data. So in very big systems, RAID 50 is widely used because when you have a RAID 5 and if you put 6 disks into a RAID 5, it becomes very slow because my MP3 file has to be split up between 5 disks and calculated a checksum. In a RAID 50, we split up the MP3 file in 2, and then we let the RAID 5 do its thing over here. It's better. The next thing is a RAID 60, and it's just about the same thing. We have our, now we need 4 disks on each side. We have a RAID 6 over here, we have a RAID 6 over here, and they're striped, so data comes in here and half of it goes over here and half of it goes over here, and we can lose 2 disks on each side and we're still good. So that's a RAID 60, just about the same. It's better security, and RAID 60 is highly recommended by storage vendors as a good system to be run on big SANs. When you get up into configurations like this, it's also commonly used to have a hot spare. A hot spare is a disk that can be a locally hot spare, or it can be a global hot spare. You can have if you have a server and you have let's say you have the operating system on 2 disks and they're in a mirror, and you have your data on a RAID 5. All of these are 100 gigabytes disks. So you might be interested in having extra security, but it would be rather expensive in disk space to do that. So here we have our server. We have a C drive, and that contains of a RAID 1 with 2 disks, and they are in a mirror. I don't know why I put that. Then we have the D drive, and that's a RAID 5 R5, and that's of course minimum of 3 disks. If this is a critical system, let's say that we have a bad disk here, then we only have 1 disk, and that might not be very good. If this is on a remote location or something like that, well, we don't like it to be running on 1 disk for very long. So what we can do, we can have a hot spare, HS hot spare, and we'll put in a global hot spare. You can have a local hot spare, and that means that this disk can be backup disk for this array, or it can be a backup for this array. If it's a global hot spare, it can be a backup disk for both of these arrays. Let's just say this is 100 gigs, right? And these are 100 gigs as well, all 3 of them. These might just be, let's just make them 32 gigs. This means that this global hot spare, because it's larger than this one and same size as this one, it can be a global hot spare. If this was like 80 gigabytes, it could only be a hot spare over here. But right now, if there is a disk that dies over here, the system will automatically mirror the C drive over on the hot spare disk. If it's a disk over here that dies, let's just say the middle one here dies, then the global hot spare will be put into this array. That means that we have a dead disk here, but we still have a RAID 5 on this array. Or if this one over here dies, we will have a mirror just with this disk and this disk instead. We don't go down in production or security. While being put into the array, we have a loss of security, but it's a lot shorter than if we don't have a global hot spare, because if this one dies, well, we get an error and we have to drive out there. And in the time that we actually get the new disk and drive out to the server, well, this one could be put in and the danger would not be there anymore. And then we have more time to make the necessary repairs for the system. When do you use one RAID system compared to another RAID system? Well, when you're running at home, you very often don't use a RAID system. On your regular PC, when you're doing your work, the normal thing is just to have a hard drive, a C drive, and it's not rated across anything. That's a very regular thing, and it's perfectly okay. Where you save your data, it's a good thing to have a RAID. If you save your data on your local computer and you only have one hard drive, well, if that hard drive dies, you lose your data. You can save it up in some cloud thing, and that's perfectly fine. They have a RAID system for you then. So if you have access and want to pay for cloud storage, that's fine. Everybody has that. Google Docs, iCloud, Amazon, Dropbox, you name it. Everything is good. You can take your very important data and save it in the cloud, and that would be good. If you have a little bit more data than that, normally you don't get like hundreds of gigabytes of data. Well, you get a NAS box, probably. That's a very regular thing to do. And the NAS box runs your RAID at your home. RAID 5 in a NAS box is pretty good. But there is different systems where you want to use some of the other ones. RAID 0, if you have a computer, for example, I do a lot of film editing, and a RAID 0 would be really good for my footage data because I have a really high access. This is very fast, but the data it's not secure, and it doesn't really matter because I need to make that film and I need to edit it and I need to save it somewhere else, YouTube for example. Here I need the speed and not the security, and that would be a really good. It could also be your gaming PC. If you have a gaming PC and you want your storage on the gaming PC to be fastest as possible, load the games as fast as possible, you would probably get two not regular drives like this, but solid state disks, and put them in a RAID 0, and that would give you one heck of a performance. Then there is mirroring. It's a bit of the same of this, but now the data has to be important enough so that you want it to be really safe. So this could be if you're doing some kind of a really big report or actual work. If I was doing, let's say that my video editing, I didn't have a backup of those data. I was working with the data and they weren't backed up anywhere. I would want to have the fast access to it, but I would also want the security for it. So in that case, a RAID 1 would be a good thing. RAID 5 is good for your everyday data. I would recommend a RAID 5 on your NAS box, except there is better RAIDs on that. If you've seen my videos on Synology, Synology has their own SHR. Yeah, Synology Hybrid RAID. They have that on their NAS boxes and it's ingenious. If you have a NAS box and it's a Synology one, I would recommend going for that one. It's a RAID 5 setup, but it does it in a very smart way, so you get more out of your disks. But it does it like a RAID 5, it's just smarter. And that's pretty good for your home data, your pictures, your local music, your film stuff. I would recommend you having a single disk backup of this one. So your everyday use, you use a RAID 5 and you back it up to a single disk. Normally your very important data is, if it's over a couple of terabytes, well then you have too much important data. So, your film collection, your music collection, they can all be downloaded, bought again. Your family pictures, your accounting, your papers, they can't. So it's all the things that you can just download and buy again. That's not important data. It's good enough for your everyday use. So if you want to have your DVD collection on your Synology NAS, well, put it on a RAID 5. It's pretty irritating to have to digitize that again, right? RAID 6 is, well, if your data is important enough, you choose a RAID 6. But now we are really up in the enterprise level of security. We are at work now. RAID 6, we are working. You might have a home office where you have important data and you could use a RAID 6 for that. You would also have a backup solution for that. You don't have RAID 6 as the only options. You have the RAID 6 in your office so that if you lose a disk, your production can go on. If the house burns down, this will not save you. Then you need a backup. RAID 10, well, you can do RAID 10 up here in the gaming things if you want that. If you really want high speed and security, you can do RAID 10. As soon as we go to RAID 50 and RAID 60 and combining that with Hotspare, we are in a data center and we are working with other people's data, and it's pricey if we lose that. So that's my thoughts on RAID systems. I am aware that everybody does this differently and have different thoughts about how to use RAID, and how secure your data has to be and how much is enough to be enough. And just to show you, up here I have my RAID system. Up here I have some sandboxes, and these runs RAID 6 with 2 hot spares each. So 14 disks, and 2 disks go out to be hot spares, and another 2 disks go out to be RAID 6 security. So I have, in a box like this, I have 10 disks of actual data. The rest is security. In a server you use a controller like this. In your regular PC, if you want to set this up, you put in 2 disks, and the normal thing is to let Windows do the RAID system. That's very common. If you want to do it really fast, you get a, probably not this one, but more like a little RAID controller like this. Very often it's on the system board. On good expensive motherboards it will have a built-in RAID controller, and that will be fairly priced. So well, I hope you got something out of this RAID rant. Do leave a comment in the comments below. Tell me how you do it, and if you do it differently, it's fine. We all do this differently. We have our own ways and our own methods, and do tell me what you think and what your security level is at home. Everybody have their different ones. Down here I have a couple of NAS boxes, which you have already seen in other videos, and they're both running, well, this one is running RAID 5 and this one is running Synology SHR. You might have seen that video. So, but thank you for watching my videos. Do subscribe to my channel so that you can see me again. Join me over at Google+, where I occasionally interact with you guys, post some pictures, throw some things around. Have a nice day. Bye bye.